Before a model based on the Transformers architecture like ChatGPT can perform well, it needs to be trained with carefully selected data. Choosing the right type of data is crucial as it shapes what the model learns. For example, if we want the model to generate conversational responses, we might choose datasets like news articles, dialogue scripts, or books. For conversational English, the dataset might include phrases like "Hello, how are you today?" or "I am learning about AI," or even "Can you help me with this problem?" etc., etc. Once we have selected the text, we move on to the pre-processing steps that prepare this data for the model. The first step is tokenization, which is handled by a pre-processing tool outside of the transformer model itself. Tokenization breaks down each sentence into smaller units called tokens. For example, in the sentence, "Hello, how are you today?" each word or part of a word becomes a token. This step is essential because it enables the model to recognize words in different phrases or contexts. At this point, we are no longer working with complete sentences, but rather sequences of tokens that the model can process and understand. Next, we move on to vocabulary creation. Since the model operates on numbers, it can't directly understand words. To bridge this gap, the pre-processing tool creates a vocabulary list that maps each token to a unique number. For instance, each token in "Hello, how are you today?" is assigned a specific number. In larger models, if the model's vocabulary contains 50,000 unique words, each word in that vocabulary has its unique identifier, and this mapping allows the model to process text as numerical data. Then comes padding and masking. The model expects all input sequences to be of the same length. Suppose our required length is 10. If a sequence is shorter, such as "Hello, how are you today?" which only has a length of 7, special padding tokens are added to make it uniform in size. Padding tokens are also assigned a unique number, such as 9, which is only an example for this course. This allows the model to recognize them as placeholders rather than meaningful content. Masking is then applied to help the model focus only on the actual content and ignore the padding tokens that don't carry any meaning. For example, the mask might look like this. 1 represents real tokens and 0 represents padding tokens, which the model will ignore during processing. With these steps, our pre-processing is complete for the sentence "Hello, how are you today?" These principles apply to all text data fed into the model. If you are interested in exploring pre-processing tools further, you can check out resources like Hugging Face, Spacey, and NLTK.